So students, let's continue with the chapter that is aldehydes, ketones and carboxylic acid, and we have started the part of the carboxylic acid, and we have studied about the naming and all the other things related to carboxylic acid. So now let's move further with the preparation of carboxylic acid. And in the preparation of carboxylic acid, we are going to start with the first method, that is the preparation of carboxylic acid from oxidation of primary alcohols. Okay, from oxidation of primary alcohols. So here the general reactions, here it will require that primary alcohol, that is RCH2OH, which is a primary alcohol. The oxidation of this primary alcohol will be taken place, that is oxidation. For oxidation, here oxidizing agents such as mild oxidizing agent or hard oxidizing agent, strong oxidizing agent such as alkaline KMnO4 can be used, which will convert the alcohols to aldehydes. Further, these aldehydes will be converted to, on the further oxidation of aldehyde, it will be converted to carboxylic acid. Okay, so this is the method for preparing carboxylic acid from primary alcohols. Here we can take an example. Here the further oxidation is being carried out with hydronium ions addition also, that is acidification. Okay, here I am taking one example, that is CH3CH2OH, that is ethanol. It is been first reacted with alkaline KMnO4, okay, so it will produce CH3CH2CHO. On further oxidation of which, okay, on further oxidation and addition of hydronium ion, it will produce CH3CH2COOH, that is propanoic acid. Sorry, I have increased out one carbon here, so one carbon will not be increased out. Here this carbon will be converted, that is ethanol, and this COOH will be CH3COOH, that is ethanoic acid will be formed, not propanoic acid. Ethanoic acid will be formed out here, ethanoic acid. Okay, we can't add one carbon out here by this method, so hence ethanoic acid will be formed out here, that is acetic acid will be formed out here. So this is your first method for the preparation of carboxylic acid by oxidation of primary alcohols. Now if we want to produce very large molecules of primary alcohols, so we can produce it by using CH3CH2CH2OH, that is decanol. This is decanol. Okay, decanol's oxidation can be carried out in the presence of CrO3H2SO4. okay, that also in aqueous solution. So this particular reagent, it is known as Jones reagent. Okay, this reagent is called Jones reagent, and on reacting with Jones reagent, here the formation of very large molecules such as decanoic acid can be formed out here. Okay, large molecules such as decanoic acid can be formed out here. Decanoic acid. Okay, So this was the method for preparation of carboxylic acid from primary alcohols. Okay, so here let's discuss about the mechanism of this Jones reduction. This particular reduction reaction, it is called as Jones reduction. Sorry, not reduction here, Jones oxidation. Okay, it is called as Jones oxidation of alcohols. Jones oxidation of alcohols. Okay, so here in this Jones oxidation, here we are using chromium trioxide in aqueous solution of H2SO4. Okay, so what happens, this chromium trioxide, this is the chromium trioxide, and it is been mixed with aqueous H2SO4. That means hydronium ion will be there. Okay, hydronium ion will be there, and this hydronium ion, it is been present here, and due to this reason what will happen, due to the presence of hydronium ion there, the the O will be having a positive charge. Okay, so here this oxygen and the due to the presence of positive charge on O, what will happen here, the repulsion between the oxygen and hydrogens will increase out here, and the formation of a bond between the coordination bond will be formed between the oxygen of the chromium trioxide and hydrogen. Okay, and here the formation of CrO2OH will take place. Okay, HCrO3, HCrO3, where O is having a positive charge, has been formed out here. Now, as O cannot hold positive charge for a long time, so what will happen here, one electron pair will be broken out from the chromium and one lone pair of oxygen from the OH group, that is from the alcohol group, and here you can consider a H here if you are considering for the 1 degree alcohol. Okay, so here you can consider the H. If you are considering the 2 degree, then you can consider R here. Okay, so what will happen, this O will donate its lone pair of electron towards this chromium atom, which is having more which has developed a positive charge due to the removal of this pi bond here. Okay, so a formation of an addition compound will take place, that is RO. Here if I am taking H, ROH, and this O will be connected to HCrO3. Okay, now one water molecule, okay, one water molecule can react here with this particular, the water molecule which has been released out here, it will just react with the hydrogen ion. Why so? Because this oxygen is having the positive charge. Here you can see this oxygen is having positive charge and hydrogen is also having electropositive charge. So what will happen, they will repel each other, and due to this repulsion it will be a attacking position for the water molecule which is present there in the aqueous solution of H2SO4, and it will attack this H plus ion, and the H plus ion will be removed out here, and the oxygen ion which is present here, it will just attack this hydrogen ion. Due to presence of this oxygen which is attached to this oxygen, this hydrogen ion attached to this oxygen, what will happen, the repulsion between this oxygen and hydrogen will take place, and it will be attached to this oxygen which is present in the chromium. Okay, so the formation of H2CrO3 will take place here. Okay, with the bond of O. Okay, now as O's electronegativity has been decreased out here. Okay, so what will happen here, the carbon which is attached to this O, it will release one more hydrogen atom which will be released to the water molecule. Okay, and further here the bond between the chromium and oxygen will break, and the oxygen's positive charge, due to the presence of oxygen's positive charge here, what will happen, the pi electron between the carbon and oxygen will be broken out, and this oxygen's lone pair will be taken back to it, and the positive charge will be satisfied here. Due to this reason, what will happen, it will get released out here, and the formation of double bond here, it will take place between the carbon and hydrogen, and the formation of aldehyde will take place here. Similarly, if you are considering the R here, okay, means in the place of H, if I am going to consider the R here, then it will form a ketone. Means here we require what? Here we require 2 degree alcohol. In the place of 1 degree alcohol, if you are taking the 2 degree alcohol, then the formation of ketone will take place, and if you are using the 1 degree alcohol, then the formation of aldehyde, that is acid. Which acid? Your acid, that is decanoic acid, or like the carboxylic acid will be taken place here. Okay. Next is the next is the preparation of carboxylic acid from oxidation of ketones and aldehydes. From oxidation of ketones and aldehydes. So aldehydes are easily oxidized. Aldehydes can be easily oxidized to carboxylic acids. Okay, they can be easily oxidized to carboxylic acid, while ketones are difficult to convert into, are difficult to be oxidized to carboxylic acid. The reason is due to presence of more plus I effect here. Okay, in the ketones more plus I effect is there, and due to this reason it is very difficult to oxidize them, while in the case of aldehydes it is less plus I effect is there, so it can be easily oxidized out. Okay, so here let's see the general reaction, that is RCHO on oxidation it will produce RCOOH. Okay, so here mild oxidizing agents can also be used, such as Tollens reagent. We can use Tollens reagent, which is a mild oxidizing agent which can produce carboxylic acid here. Okay, for example, such as ethanol is taken on treatment with Tollens reagent, it will produce acetic acid. Okay, while ketones can be oxidized with strong oxidizing agents. Okay, it will require strong oxidizing agent for the oxidation process. The third is the preparation of carboxylic acids from hydrolysis of nitriles. Hydrolysis of nitriles. Okay, so here we can take the example, the general reaction as RCN plus hydrolysis means to react it with water. Okay, in the presence of either H plus or OH minus ion, that is in the presence of acid or either the base. Okay, so what will be found out here? Here first we will convert the RCN to, it will be converted, the nitriles will be converted to amides. The nitriles will be converted to amides, and further this amides will be converted to carboxylic acid with the removal of ammonia gas. Okay, with the removal of ammonia gas here. So here we can directly convert the ammonia also, that is amides also, that is RCONH2 on hydrolysis. Okay, on direct hydrolysis and on heating it will produce carboxylic acid plus ammonia. Okay, carboxylic acid and ammonia. So why it is done so? Here you can see that H plus and OH minus will be released when water is being broken out. So H plus, it will just move with that of the ammonia, that is NH2 here, and OH minus will get attached to the carbon atom. Okay, sorry, not oxygen, it will get attached to the carbon atom present here. Okay, so this is the hydrolysis of nitrile. So let's discuss the okay, so let's discuss the mechanism of this reaction, that is conversion of nitriles here. So here, when nitriles are reacted with water, okay, so what happens there? Let us say a H plus and OH group is there, okay. So what will happen here? The RCN, that is the nitriles, they will attack the H here, okay, and the hydronium ion, the ions, that is H3O plus is there, okay, H3O plus. So here they H3O, not HO3, here H3O plus is there. So they will attack one of the H plus H ion by the nitrogen here, and the formation of R C double bond N H plus will take place. R triple bond R C triple bond N plus H will take place here. Okay. Further, as the positive charge is here on the nitrogen, so what will happen here? One pi electron will be shifted out to the nitrogen here. Okay, and the formation of what will take place here? The formation of a compound, that is R, and this compound, that is H2O, will get attached to the carbon atom here. Okay, so the formation of R C NH double bond OH2, it will take place here. The tautom, as this compound is very unstable, so the rearrangement and the tautomerization will take place, and the double bond from N, it will shift to the O, okay, and one more H, it will get shift to the N here. The formation of amide will take place. Okay, the formation of amide will take place. Now further water molecules get attached to the carbon atom here. Okay, so the addition compound, that is COH O plus H2, okay, because oxygen has donated the electron to the carbon, NH2 and R group here, it will take place here. Okay, this is an adduct compound. Further, on acidification, what will happen? This oxygen will transfer here, okay, and due to this, what will happen? The formation of here NH3, okay, it will take place, and the removal of NH3 will take place, and it will get converted to RCO H plus and H. So as we know that the NH3 is also present here, na? So some of the NH3, it will get attached here with this H, and they will remove this H. Due to this, what will happen? The formation of RCOOH will take place, and some byproducts such as NH3 as well as NH4 plus will also be found out here. Okay, so this is the mechanism for the hydrolysis of nitriles and amides. Next is the reaction from the preparation of carboxylic acid from the Grignard's reagent. Okay, from Grignard's reagent. So Grignard reagent. When Grignard reagent is reacting with the when Grignard reagent is generally reacted with carbon dioxide, okay, carbon dioxide, CS3 MgBr. We have taken an example of methyl magnesium bromide here. Okay, so here the breakage of the compound here, it will take place C minus and Mg plus, C minus Mg plus, and here when this Mg, it will attack towards the oxygen here, while the CS3, the negative part here, it will attack towards the C of the carbon atom in the presence of dry ether. Okay, so here formation of a adduct compound, that is CS3 C O OMG Br will take place. Further on acidification or hydrolysis, sorry, not acidification, that is hydrolysis. Here we will obtain CS3 COH plus Mg OH Br. Okay, so the acetic acid is been obtained out here, and magnesium hydroxy bromide is produced out here. So here you can try by yourself that what will happen when you are combining ethyl magnesium bromide with carbon dioxide. So try by yourself. Okay, next is the preparation of carboxylic acid from acyl halides. Acyl halides. Okay, so from acyl halides, acyl halide means RCOCl. Okay, R C double bond O Cl. I am taking the example of acyl chloride. Okay, so here on hydrolysis of acyl chloride, formation of carboxylic acid, and here hydrogen chloride will take place. Is it clear? Okay, so here you can take different examples, that is CS3 CO Cl H2O. Okay, so it will form CH3 COOH plus HCl. So what is the mechanism here? The real mechanism here, it can be seen out that when RCOCl, it is reacting with the H plus and OH minus produced by H2O. So here the H plus ion, okay, it will form RCOO minus, which on further hydrolysis, okay, on further hydrolysis it will get converted to RCOOH. Okay, and the formation of HCl is obvious, it will take place here because H plus ions are present, so Cl minus will get attached to that H plus ion there. Okay, next is the hydrolysis of anhydrides. Hydrolysis of anhydrides. So there what will happen, RCOO, okay, that is R2O, okay, R2O, on hydrolysis they will prepare 2 RCOOH. Okay, so here one example can be taken out, CS3. Okay, sorry, I have written the wrong formula here. The correct formula, it will be RCO twice O. It will be anhydrides. Okay, it will be anhydrides, acid anhydrides. So CS3CO twice O, on hydrolysis it will produce 2 times CS3COOH. Okay, this is acetic anhydride. Acetic anhydride, and acetic anhydride is producing acetic acid. Acetic acid. Okay, next is the hydrolysis of ester. Hydrolysis of ester. So hydrolysis of ester, that is R COOR dash plus H2O, where H plus or OH minus will be there. Okay, So it will produce RCOOH plus R dash OH, that is carboxylic acid and alcohol will be produced out here. Okay, so here I am taking the example of CS3 COO CS3. Achha, you have to take R dash na, so I can take here C2H5, then the formation of, in the presence of H plus and OH minus, the formation of acetic acid, that is the smaller chain it will form the acid and the larger chain it will form the alcohol. Okay, so this is the compound formation. Next is the physical properties. Okay, these were the last preparation method. Next is the physical properties of the carboxylic acid. Physical properties of the carboxylic acid. Okay, so the first physical property, number one, is the physical state. Okay, so first three members are colorless liquids. And have pungent smell. The next six are oily liquids. With faint unpleasant smell. Faint unpleasant odor. Further are waxy solids. While aromatic acid, that is benzoic acid, are colorless solids. Benzoic acids are colorless solids. Next is the solubility. So as we know that the acids, they are, from name only we can see that they are acids. So first four members are soluble in water. And the solubility decreases with the increase in the molecule carbon atom. The solubility decreases with gradual increase in the number of carbon atom. With gradual increase in the number of carbon atoms. Okay, however, higher carboxylic acids are soluble in non-polar solvents. Such as benzene, ether. Okay, all they are solvent. Next, boiling point. Third is the boiling point. One more thing which can be discussed out here is that why with the increase in the number of carbon atom, here the decrement in the solubility has been observed out here. The reason is that with the increase in the number of carbon atom, the alkyl group or the molecular size or molecular mass increases, due to which the hindrance provided by the large bulky groups to the carboxylic acids for taking part in hydrogen bond is been hampered out there. Okay, and hence the hydrogen bond which can be formed out with water for the carboxylic acid, it has been reduced there, and due to this reason what will happen, the sparingly soluble condition will be obtained when the number of the carbon atom is been increased out in the carboxylic acid group. Okay, next is the boiling point. So carboxylic acids are having higher boiling point due to presence of intermolecular hydrogen bond. Okay, as they have intermolecular hydrogen bond, they have higher boiling point than corresponding alcohols, aldehydes and alkenes. Okay, for example, if you are comparing for acetic acid, the boiling point is 390 Kelvin. For propyl alcohol, okay, that is C3H7OH, it will be 370 Kelvin. For propanol, it will be 322 Kelvin, while for alkane, that is CH3, CH2CH3, it will be only 309 Kelvin. Okay, so they are having relatively higher boiling point as comparison to the corresponding compounds there. Okay, corresponding alkanes and aldehydes and alcohols. Next is the, also if you are comparing the that is HCOH, that is formic acid, it will be having 373 Kelvin boiling point. For acetic acid, it is 390 Kelvin. For propanoic acid, it will be 424 Kelvin. So with the increase in the carbon atom, the gradually we will see that the boiling point is increasing. Okay, with the increase in the number of the carbon atom, here the boiling point will also be increasing out there. Next physical property is the melting point. Okay, next is the melting point. So the melting point of the corresponding, as the number of as the molecular mass or the number of carbon atom is increasing out there, the melting point of the carboxylic acid is also increasing. Okay, from the melting point of the carboxylic acid increases irregularly with increase of molecular mass. It has been observed that for the first 10 members, the melting point of carboxylic acids containing even numbers are having higher melting point as comparison to that of the next lower and higher member containing odd numbers of carbon atoms. For example, if I am taking an example here, CH3 CH2 COOH, CH3 CH2 CH2 COOH, CH3 CH2 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 COOH. Okay, so here we will see that the melting point here is 251, here it is 237, while here for the 4 carbon atom compound, here it will be 267 Kelvin. Okay, so the even number compounds are having higher melting point temperature as comparison to that of the odd number compounds of the carboxylic acids. Okay, so I am concluding the class. I am concluding today's class here only with the functional physical properties of the carboxylic acid. In the next class, I will just discuss with you the chemical properties of the carboxylic acid. Okay, and after this we will continue with the next chapter, that is the nitriles only. Okay, and I will try to complete this particular nitriles also in the video part only. Okay, so you must go through the videos which I am posting according to the timetable you have been provided, and it will be easier for me to complete the course as well, and it will be more sufficient also for you to understand this particular reactions, as I am showing you the mechanisms also here. So it will not be easy for me to conclude all these things in the live classes, so it will be easy for me also and for you also to see the videos. So go through these videos and don't leave any of the videos I am posting for these two chapters for the organic chemistry. That is, one is the carboxylic acid, and the next one will be the nitrogen containing compounds, nitrogen containing organic compounds. Okay, so thank you for today. We will meet up in the next video.